All right, welcome everybody. Let's see. So we started earlier this week talking about Node.js as a runtime environment that is going to allow us to create HTTP servers using the Node.js interpreter, JavaScript interpreter, right? And we're going to be using a library called Express, right, to create HTTP servers from scratch, right? And we're using this as a middle tier solution, right, to compensate or complement, right, the front end that we've been working with in using React.js, right. That there are some limitations that doesn't allow us to store data permanently, right. That we want to be able to maintain the state in a broader context, right. So we've been exploring ways that we can have data live in the server's memory, right, and be able to interact with those data structures in the server, right. We explore ways that we can send data to the server, right, that we can manipulate objects on the server, right. Today we're going to be taking a look at something more complex, like working with arrays, right, and also we would like to look at ways that we can better integrate the user interface so that it can, interact with the server by fetching data in the background, right, and then updating the user interface based on the data that the server responds. Okay, so that's what we're going to be discussing today. Also, the exam was moved to next week. And what else? The assignment is due later today. And what else? And I will make available the answers to the first exam so that you can reply to it, right? If you find, you can take a look at your answers and check how perhaps you feel that you might be owed a couple more points at a particular question, right? So yeah, so that's going to go out later tonight, and so please take a look at that at the exam, your answers, the right answers. See, maybe you misspelled something, right? So go over that and let us know if we need to give it a second look. All right. What else? All right. So any questions? So we're wrapping up the 8th week over here, where we are covering introducing how to implement the client server architecture. And we've been working for half the semester. For the first half of the semester, we've been working implementing a React.js client user interface, right? That can maintain its own state, but obviously when you refresh the screen, the browser, right, the all information that you might have created is reset to the initial values, the default values of the state variables, right? So we want to be able to survive that refresh, right? Actually, we'd like to be able to maybe identify ourselves, log in, and the entire state be maintained permanently in some database, right, in some server, so that we can authenticate, right, and then all our state, right, is permanently stored, right, in some long-term storage solution. Okay, we'll first start how that occurs at the server level, right, and then next week, right, we'll start discussing how that can happen also at the database level, right? Yeah, so we're here at talking about interacting with the server using the Axios library. That is today we're going to talk about the Axios library and how it implements the Ajax architecture. Okay. Anyway, so that's what we're doing today. So let's just review real quick where we left off with the code. On the server side, node mon, we have a server that we implemented with JavaScript, right, and a couple of routes, right, that we can have the server respond to us with the data, strings, objects. Today we'll take a look at arrays, and we can also have it expose data types, right, mapped to certain URLs, right, that we call routes. That if a path comes in, right, these routes can handle those requests, right, and be able to respond, right, with data, with strings, with arrays, with objects, right. In these examples, we showed how we can create to-dos or manipulate arrays, right, and so all that is covered in our new A5 assignment, which is going out today. So I'd like to share that with you, and so we can review what we've looked at so far, right? And so we can move forward, right? So let's see. Are we CS5610 git status? Oh, there's no git here. But yeah, we worked on lat 5 all the way to last earlier this week, right? We worked on interacting with objects. I guess we had started just with the arrays, deleting content, retrieving a particular to-do, right? Yeah, so let's go over the assignment 5, and that will give us a chance to revisit all the material that we covered earlier this week. Okay, all right, so let's take a look at assignment 5. So this should be available now to you if you want to start working on that, right? After the you submit assignment 4, you can start working on assignment 5. So this is going to give us a chance to review what we worked on early this week, right? So first, there's some blurb about the history of client-server architectures. Also installing and configuring the Node.js HTTP server. A little bit about the architecture that what we've been working for the last month or so, right? That we have been building a client-server application, mostly focused on the client, that we'll be building a browser React.js client, right? And now we're going to be focusing on implementing the server side of this client-server application, right? And that the interaction is through a set of requests and responses, right? That other than that, these two projects, these two processes, right? They are entirely independent of each other. They just happen to know about each other through an HTTP URL, right? That you can send requests from one to the other, and the other one can respond to those requests, right? So just go over the fact that you should have Node.js installed, and that in a separate directory structure, not inside of the web application that we already have, right? Separate from here, right? In a separate directory, you can create the Canvas node server app directory, and in there, you go in there, and you can initialize it as a brand new project doing npm init. We then illustrated the creating a very simple hello world JavaScript file that you can run it from the command line. Then we got started implementing the server in earnest, right? There's a question in the chat. What is the difference between Node and Express and Render.js? So Node is a JavaScript interpreter. It's a command line runtime that can run JavaScript, right? Just hello world, right? And like any other language, right? The language by itself is not very interesting, right? What makes the a language interesting is the set of libraries and the community that creates open source and creates all sorts of infrastructure and resources that others in the community can use. So Express is one of those libraries. It's a JavaScript library, right, that is written in JavaScript for the Node.js runtime, right, that adds the capability of implementing HTTP servers. I mean, you can create your own HTTP server from scratch using plain JavaScript. You know, after several years of engineering and optimization, you would end up with Express. Express is just a library. It's one of the most popular libraries, right, that allows you to very quickly, using Node, right, implement the HTTP servers. And it's a library that we've been using so far, right, to create all those routes. So app.get, app.post, right, request params, request query, all that syntax that we've been using throughout the earlier this week, right? That's all the Express library running inside a Node.js environment. Now, Render.js is a hosting service, right, that allows you to run Node.js remotely on somebody else's machine, right, for a fee. You can pay, just like Netlify. Netlify is a service that you can tell folks, hey, run this Node.js server that is hosting my React.js application, right? And that's what Netlify does. So Render.js is equivalent to Netlify, but right, it specializes on the middle tier in implementing server-side technology. Although it can also host web applications as well. But we are going to be using these two remote solutions, right, to illustrate the fact that, right, these two are separate processes, right, that one could be running, halfway across the world, talking to another one, right, that is, again, on the other side of the globe, right? And they can still talk to one another as long as they know the IP address, right, of where these machines are. So Render.js is the equivalent of Heroku, AWS. These are all hosting services. Make sense? Right, so we created app.js, we can start it. We configured node bonds so that we don't have to restart the server over and over, right? And then we configured our Node.js to use the new module syntax, right? So that we can do import instead of require JS. So we were able to do import as opposed to require. Then we created routes, right? And then that we had written it inside of app.js, right? And then we moved it over to another file, the hello.js. Then we wrapped it inside a function so that we can pass in a reference to the Express library instance, excuse me. And then we imported it and we passed a reference to app to it, right? So that it can implement all these routes. So this is using the Express library. Right? See, we import the Express library, we create an instance of it, right? And then we pass it around. There can only be one single instance of the Express library, for any one Node.js instance, right? So you can't instantiate a whole bunch of these, right, wherever you want, right? It's only instantiated once and then passed around wherever you need it. So here we are passing it to the hello function here, right, so that it can then use it to declare a whole bunch of routes. Okay. Okay, then we started working on labs, right? We created really simple, hello world, hello, welcome to assignment 5 lab. We imported it and again passed a reference to app to this new lab 5. Right? We then explored how we can integrate, right, React.js applications with this new server, right? And for now, we're just trying out doing hyperlinks, right, where clicking on a hyperlink, right, navigates to that server, right? And notice that that our React.js application is running on localhost 3000, whereas our server is running on localhost 4000. right? Making them effectively, two entirely separate processes, right? Running at different, it's as if they were running on different IP addresses, half across the world, right? One is running on the East Coast and the other one was running on the West Coast, right? And they communicate by, knowing the URL of the other. We then explored several ways of sending data from the client to the server, and that we mentioned that there were three basic ways. One is that we can encode data as part of the path, right? Embedded as part of the path elements. The other one is embedded at the end of the query, right? Where you have a question mark and you provide several name value pairs, right? Like, A equal 2, B equal 5, separated by ampersands, right? You can have any number of attributes, and then you separate them by ampersands. The third way, which we haven't discussed, right, is the passing data, embedded inside of HTTP bodies, right? And this is the most flexible one, right? It allows you to attach any size message encoded in any format that you want, right? You can encode it, you can encrypt it so that nobody can see it, so it's safe, right? And it can be of any size, right? So bodies are, by far the most versatile ways of passing data to the server from the client. We'll take a look at this a little later today, right? But the first several exercises worked on path parameters and query parameters, right? We first looked at path parameters, then we are going to look at, first we looked at path parameters, then query parameters, and then we're going to use a mixture of both, right, to learn how to work with objects, arrays, and then finally we'll talk about using body, right, passing, retrieving data from the server, and also passing data using the JSON embedded inside of bodies, right? So anyway, we practiced path parameters. We implemented a little calculator that you can pass in, parameters A and B, and you can add them and subtract them. That was pretty fun, right? Including the user interface to interact with it. We worked also on query parameters that, right? We created routes, right? That instead of using query params, use query request query, which were parsing these parameters at the end of the query, right? And we implemented a couple of links to test the add and subtract. So here's a list of the exercises that you need to complete. Then we played around with objects, right? That you can declare objects, right inside of the server, and then you can make it available to the rest of the world through these through these URLs, right? So you can declare objects, right? Oops. And then these objects you can expose or make available this data through these routes so that anybody can access your assignment. We created a little user interface for that. We also saw that we can retrieve not just one object, but maybe a particular property inside of the object, right? Using providing, we wrote this right. Now, just to point out, right, that this string that defines this URL is completely arbitrary, right? You can put any unique string is good enough, right? Now we are using a naming convention of using paths, right? But really, any unique string would work. And the fact that we're using slashes is a mental model for us, right? That this has some kind of hierarchical partition, but not really, right? It's just a convention. Chat. How is the path in the app.get call different from the path in the route element in React, if at all? Well, these are completely two different processes, right? One is running in on a browser, right? And you're interacting with hyperlinks that are being interpreted by JavaScript running on a browser, and based on the URL, it's deciding to display one component versus displaying another component, and it's entirely graphical, right? And this is entirely running inside of a browser. This here is not running on a browser, right? It is running on a server, right? That has no notion of what a browser is. It is using paths as well, right? But these paths are being handled by the server. The server is parsing these URLs, right? And then calling these functions for you that you can then handle, right? So, and there's no user interface whatsoever. And it has no notion of a button or an input field or nothing, right? So these are completely two different technologies, right? But they both use routes, the name routes, because they are paths that are mapping some URL in the browser, right, to some execution, some logic. In the browser, the logic is to display one component versus another component, display one screen versus another screen, whereas on the server, right, is the route, the URL is used to execute a function, right, that generates some data, right? No user interface whatsoever. Okay, so it says, I know the operations are different, but the paths themselves, do they relate to one another or are they completely independent? They're completely independent, right? How routes are handled on the browser, they're completely different how they're handled here, right? And now there are some similarities in the naming convention, in some of the characters and syntax that we use. For instance, in React, the routes use the colon, right? The colon to define a path parameter. Here too, we use colon to define a path parameter. In the browser, React.js, we use hooks, right? These is JavaScript that can parse the URL, right, and provide an object from where you can parse the parameter, right? Here we use it's the request response, right? The request comes from the client, the request comes to the server, and then on the server, right, you can then parse the URL, right, so that you can extract those parameters using request.params. On the browser, all these hooks are all running inside of your React application, right? They never go out. They never go out to a server or anything like that, right? They're all being handled within the browser, and as the URL changes, right, the React.js application chooses what component to show, okay? Whereas here, right, the URL is leaving, right, is coming from the client. The client is sending this URL to the server, right, and the server receives that URL, pattern matches it with any of these routes that you declare here, and when it matches, right, it runs one of these functions, and these functions are meant to compute some data, run some algorithm that provides data for a front end, for somebody who is requesting. And in our case, the client that is requesting this data is implemented as a browser, but it could be a phone. It could be a phone as well, right, that is hitting this server, going out to a server, right? And so it's this, right? So it's so the routes in the browser in React.js are handled by the browser, right? So as you click links inside of the browser, right, they are handled by within the browser, and they show different screens, right? And those are implemented using the React router DOM elements, routes, link, route, okay? And that's our handle inside the browser. Now, what we're doing here is that the browser is sending requests, HTTP requests, over to some other component, some other machine, half away across the world, sending an HTTP request, sending a request. When it gets to the server, the URL, right, looks very much like a route on React.js, but it's no longer being handled by the client, right, by the browser. It's being sent over to a separate server service, right, that is running a totally independent process, right, from the browser. And because this is running outside of the browser, because this is JavaScript that is listening for this request and exists outside of the browser, it can do things that the client can't do. The client running on a browser using those routes and whatnot has certain limitations because it is running inside of a browser, right? It can't go to the file system. It can't connect to a database. It can't do, unfettered network access, right? So it's limited for security purposes. But, our Express.js application running on Node.js outside of the browser is not restricted, right? For the same security purposes, right? It can access the file system. It can connect to a database, right? It can connect to any network connection, right? Because it is running outside of a browser and it doesn't have those limitations. For the client or requests, the anchor and button href is how we send the request. Yes. And the URL is being picked up by the server. Correct. Yep. Right. So notice that the our URLs in the client application in our A5, right, all our requests, right, are going out to HTTP localhost 4000, right? It's going out to a completely different server, right, that is outside the jurisdiction of the React application. It's being picked up by the server running at localhost 4000, right? And this part here, this part right here is what is getting handled, right, and pattern matched against these URLs running on the server. And when they match, well, then your function runs, doing whatever you tell it to do. And then here, the magic is that we want to grab that data coming back from the server. We want to pick up that response from the server, right? And then make some changes here in the user interface, based on the data that's coming back from the server. Okay. All right. Okay, excellent. Yeah, very good questions. Okay, so it looks like, okay, so this is A5 prep. Oh, so I'm not in the right. So the URL hierarchy of the browser doesn't need to match the server path hierarchy. Exactly. So this when you run your React application, right, npm start, all these routes, where to go? Okay, yeah, here. Yeah, all these routes, right, of navigating whatnot here have absolutely nothing to do with what the server, Node.js server is doing, right? In reality, see this hash here? That hash says that we are still at index.html. We never left index.html. Right? From Node.js point of view, running here our React.js browser, we have never left the URL index.html. We're still in index.html, right? Running the JavaScript and everything after the hash, right, is just fake, right? Is just JavaScript. It's capturing that change after the hash, right, to run the mechanism of showing certain components or not, right? So if I click on courses, notice that I'm still in this XML. I've never navigated away from here, right? Obviously, if I type something else, 4,000 something A5 to-dos, this is as if I would have gone, to Wikipedia, right? I went to Wikipedia. I went to a completely different URL, and this is what that server is giving me, right? So this is so that's as equivalent as going to localhost 4005 to dos, and this is what this is giving me, right? An array. Okay, so these are completely different two separate systems, right? And the way they are going to talk to one another is by sending HTTP requests and responses to each other, right? When I go to Wikipedia, the request goes out to Wikipedia, and Wikipedia responds, the server of Wikipedia responds with me with an HTTP response, right? That includes HTML. Just that's my son. Sorry. These are completely two separate systems, right, that are exchanging HTTP requests and response. Okay. All right. Okay. Yeah. Excellent questions. Excellent questions. Let me see, what branch am I here? Am I in here? Okay, branch. Okay, let me go back to my A5 branch where we left off, right? So check out A5. Okay, A5. And on the server too, see what branch am I in? Oh, I don't have Git. I don't have Git here. That's fine. So here in now that I am back to where we were here at A5, let me look at what do we do for A5? We worked on, okay, I guess we started working with arrays. Okay, we started working with arrays, very good. npm start. And let's see, so let's go to the labs. And assignment 5. Yeah, so we started working with arrays where we were updating to-do titles, right? Fetching a particular item by its ID, right? Oh, the server's not running. So let's run the server. Okay. And let's put this over here. There we go. So we can retrieve the to-do item. We can update a title. There it is, right? So we are going out to a server, and this A5 to-do's title is coming to, so there's the URL is coming to here, and it's pattern matching. I'm guessing this one, right? Which parses the ID of the to-do that we use to find the to-do. And when we find it, right, we then modify the title, right? And then we respond with the to-dos, right? Right. So we started working with our arrays. Very good. Excellent. Okay. And where did I put the assignment? Is this the assignment? Okay. So let me put these together so that wait, how can I move this here? Can I move this here? Okay. No, how do I? Huh? I guess I could go to localhost 3000. There we go. This is labs. 5. Okay, perfect. I don't really need this. Okay, so let's keep going. So here, and I guess I can close this, and I can close that. So yeah, we were working with arrays. Let's continue. So we're retrieving arrays, right? We have the arrays, and we made it available through this URL to retrieve all the to-dos. Then we looked at retrieving items, a particular item by its primary key. Okay, right, which we use to just just parse the ID and find that particular to-do by its ID primary key. And then we created a little user interface that allowed us to fetch an array by its ID, right? And it works. Then filtering item by using query strings, right? So this kind of goes back to the question that, yeah, I mean, we do have two ways that we can send data to the server. One is using path parameters, and the other one is using query parameters, right? So those are two different skills, right? And the question is, well, why would we use one versus another? Why are there two ways of doing the same thing, right? And so, so here's the basic answer, right? Is that if you are going to retrieve, right? So here's the first example of when would you use a path parameter versus a query string, right? So the convention is that these URLs, I told you earlier, right? They could be anything you want, right? They're could be arbitrary what you name these things, right? And what naming convention you choose. But there's a very strong naming convention, that states that in these URLs you should only have nouns, right? And no verbs. Okay, so we'll look at that a little later. But another convention says that that also in this in the path, right, you should only include nouns and primary keys. Primary keys, right? For instance, the unique identifier for a particular element in some data structure, right, or some collection. Like, for instance, in this array, right? These ID uniquely identify objects within the array. So encoding an ID, a primary key, as part of the URL is a legitimate use of encoding, right? So the question is, well, what about if I want to? So this one allows me to filter. This ID allows me to filter, right, and retrieve a particular object by its primary key, right? But what if I want to filter in another way? For instance, I want to filter, and say, well, I want the to-dos that are completed, right? Or if I had a due date, I might say, well, I want the to-dos that are already due, all right, or are not yet due, okay, or are due next month. Those are other ways that I could filter the to-dos, right? But none of those are primary keys, right? The completed flag is not a primary key, right? A due date is not a primary key. How about another field where it's the assigned person? Who is this assigned to? So some to-dos are assigned to Alice, some are assigned to Bob. Those are not primary keys, right? So if you're going to filter a data structure by something other than the primary key, then the convention is that you would use query strings instead of instead of path parameters. Okay? So let's do that, right? So here, right, if I can retrieve all the to-dos, it's the URL /i, /a5/ to do. Okay, and I can retrieve one by providing the ID. Perfect. That meets the convention. But if I want to filter out and say, well, I want the ones that are completed, I would not do something like something like completed, completed true or something, right? This would break the convention, right? Completed is not a noun, right? It's an adjective. And so you would not do that. Instead, you would use a query string. You would say query completed equal true. That's legitimate, right? That is part of the convention, right? You can provide several name value pairs, and you could be, if you have a lot of things that you want to filter by, right? Then you can say, completed equal true, assigned to Alice, right? And due date, right, equals today or something, whatever, I don't know, right? And you can provide multiple filters that you then need to implement, right? On your server side, you would have to implement the algorithm that filters the to-dos by this URL. So let's focus on just one of them, completed equal true. Right? Notice that right now, if I do enter, it's implemented. What? Did I implement it? Maybe I implemented it. To do, I guess I did. I don't know if I implemented it last lecture, but here it is, right? This one is that it's retrieving the query, which includes all these completed, assigned, due date, right? I'm only extracting completed, and I'm checking to see, is it even defined, right? Is there a property called completed in the query? So if it's not there, if I do that, then this would be null, right? Or would be undefined. So if it's undefined, it would not do this part, right? And it would just return all the to-dos, which is what's happening here. But if I do provide completed equal true, then this is not undefined, right? This is not undefined. Now the completed coming back in from the URL is a string. So the string true or string false, right? Which what I do is that I compare it against a string, and then if it's true, if the strings are the same, then this local constant is true, which is a Boolean data type, which I can then use to filter the completed flags, right? These flags are Boolean, not strings, right? So that's how I filter them out, and then I collect all the to-dos, right, that match that criteria, and I respond with that array of to-dos, right? And then I return immediately. See that? Because this response doesn't necessarily stop the execution, it continues, right? If I don't have the return, it would just continue after the if statement, and then it would send another response, right? And that's a no-no. You can't have more than one response, right? If one request comes in, there can only be one response. If I try to do two responses mistakenly, right, then the server would complain saying, no, you can't do that, blah, 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 right? The response has already been generated, shame on you, right? So only one request. So that's why I do a return right away, because I don't want to fall into sending a second response. Everybody okay? All right. So I'm not going to work on the front end, right? On the front end, okay, it's a question. So the completed here is a string, not a Boolean. Correct. Yep. Anything that I put here, anything that I pass through the path parameter or query parameter is all a string, right? And then it is your responsibility, right, to convert it into either an integer or a Boolean or a date, the correct data type. In the order that we put if the order that we put the path parameters, then what convention should we follow? In the order that we put the path. Oh, okay. So are you saying are you saying that whether I declare this path or that path in the order? Is that what you're saying? Or are you saying within here is the order in which I build this URL? Which one? The order in which they're declared?
Yeah. So last class you mentioned yeah, like the order you put the class, like those ID.
Yeah, exactly. So there is an importance on the way in the order in which you declare the URLs, right? The routes, right? So for instance, and I don't know if we demonstrated this. So let's take this to-dos ID. Like look at this one, right? So I'm going to move it up here. I'm going to declare it right up here. Okay. So I want you to compare this route with this route, okay? And if you notice that this one, they share the same starting string, right? They only differ with this /create and this :id. See that? But this :id is a placeholder, which means it could be anything, right? So which this ID could be the string create. No, it could be anything. So that means that there is a ambiguity between this URL and this URL, because they both could have exactly the same value at any one point, right? So the question is, well, if I say A5 to do is create, which one do I mean? Do I mean this one, or do I mean this one? Because it would match this too with the string create. There is no rule that says that these have to be integers, right? So the answer is that yes, the order matters, right? And that the pattern matching algorithm first checks to see the first path before checking the second one, right? In the order they were declared, right? So here it would first check on this. If this one fails, then it goes on to the next one, right? Doesn't mean we need to place all the path that contains placeholders first. No, the other way around. You want to put them later, right? Because this is a specific value create, right? That if you put, so notice that if so say I do the create, right? If I say to-dos /3, that's 3, right? But if I say create, it creates a new one. If I said again, it creates another one, right? So it's creating several. So that's running that portion. But if I say 3, it runs this portion, right? Now, if I invert it, and I put this one first, it won't work anymore, right? So if I say 3 or 2, that still works, right? But if I say create, it's going to consider that a primary key, right? And it's going to look for a to-dos whose ID is create, and it's not going to find it, right? So if I say create and I say enter, notice that it says to-do not found, right? Because it's interpreting that as an ID, right? So that's why if you have something more specific like this one, it's a good that you have cases where this ambiguity, then you want to make sure that they match in the right order. The difficulty happens when you want to say, oh, I want to filter by to-dos, and then you create here something that says, oh well, I want to filter. You create another one that says, I want to filter by completed, right? And then you implement here your algorithm for completed, whatever, right? And because these names are different, you'd think, right, that somehow they are distinct, but they're not, right? They have exactly the same URL pattern, right? It's A5 to do's whatever and A5 to do's whatever. But this will never execute because first it'll match this one. It will never match this one, right? So your code here, you could get very frustrated and put code in here, and you're saying, why isn't it working? I'm sending, A5 to do's /true, and it should be running this, right? And it's not, because then true would be matched with this, right? And you would return always with a to do not found. That makes sense? Right, so careful, right? The name of the parameter makes no difference, right? It is the pattern that makes a difference. Okay, all right. Excellent questions. Excellent questions. Right, so now I can create. Okay. Yeah. So we did completed, right? We and then we created a little UI to retrieve the completed, creating new items. We did that. Create. Deleting an item. Do we implement delete? Yeah, we did. So delete right? It ends with a first you identify the item here. Again, these are totally made up, right? These URLs could be whatever, right? This could be whatever, right? It doesn't really matter, right? It's whatever I give it the meaning to this, right? It could be a different language entirely, right? It could be Chinese or Indian or whatever, right? Or Hindu, or whatever language you want to put in there, right? It's whatever string character combination you want to put in there. So here I'm parsing out the ID, and I'm identifying which does it exist, right? Is there a to do with that ID? If not, right, I respond with that 404. And if there is, I'm going to splice out that to do, right, and then return the remainder to dos, right? So here, if I want to say I want to identify, say, this one or number 4, I say 4, right, and then that returns that one, and then I can delete it. I can say delete. It's gone, and it comes back with the remainder of the to-dos, right? So 4 is no longer there. Or if I want to delete 2, I can delete 2, right? And then I just have 1 and 3. Again, no UI, no React.js, no, not whatever, right? To integrate it, we need to go back to the React application, create links, and that's what the assignment asks you to do. Create a little UI on the React side that you can type the ID of the to-do that you want to remove, and then that ID is then encoded, right? That ID is encoded in the URL, and then we append the /delete at the end, right? So that it's as if we would have typed it here at the URL of the browser. Updating, we have we are let's see. For delete, could we use the .filter method like we had? Yep, absolutely. You could do that too. Yep. So for delete, the way I implemented it was that I would provide the ID of the to-do, and then the property that you want to modify, right? And then the new value that you want to set it to. So the way I implemented it was we're parsing out the ID and the title here from the parameters, and we are finding that to do with the ID, right? Notice I'm not doing any error handling. Like if I don't find it, I should return a 404, right? But I'm not doing that. And then I update the to do with that title, right? And did I implement that? Let's see. Did I implement that? Let's see. And I guess not. Oh yeah, no, new title. There it is. To do new title. Yeah. So if I look at all my to-dos and refresh, and I want to change the title for number 1, I can say 1, and then I can say the title make dinner, right? So it changes and then returns all the to-dos. Did we newly create objects? Did the newly create object get deleted as well? Yeah, well, no, what happens is that probably when I make a change in my server, NodeMon restarts. And once NodeMon restarts, it resets my array, right? So while development is happening, I'm going to have a lot of restarts and resetting. Once this is running, right, in production, it'll be very, very seldom that the server reboots, right? So the memory of the server would be much longer context, right? Especially if you're in a paid environment, right? That this is being hosted on AWS and you're paying for it. The server can be up for days, right? If you're not paying for it, then usually your server will have a timeout, right? And the server will go to sleep, after say 30 minutes of not being used. an activity, right? And then it'll be restart, right? And it'll reset all your variables. So yeah, this would be a solution for. It's a temporary solution, right? It's us learning how to interact with a server. Not that we would be using these variables, right, to store data. In the end, they need to be stored in a database, right? Not here in these variables. Okay. Yeah. Okay. So let's keep going. So we can change the title, and so here's a little UI that I ask you to implement to update the title, and then I ask you to create other ways of updating updating other properties such as the completed flag or the description flag. Okay. All right. So all that is to say that we can interact with the server by just having simple hyperlinks. But that's not really the ideal way to interact with the server, because notice how we are basically leaving our React application. We're leaving our React application 3000. And we want to stay in the React application. We want to be here, not navigating right to a server and seeing data. I want to stay in my application and never leave my localhost 3000. I don't want to have to go to localhost 4000. That's a completely different website, right? And it's giving me this data, right? It's not rendered in any way. It's just raw data. I want to be here in my React application, somehow, behind the scenes, go to the server, but never leaving here, right? Go to the server behind the scenes somehow, right? Capturing this response, and then in the user interface, render the content that came back from the server without leaving my React application, always staying at localhost 3000, right? So how do we do that? So we're gonna be using a technology that has been around for quite a while. It's called Ajax, right? And it was designed, implemented specifically for this type of use case, right? We want our JavaScript applications running on a browser, making requests for data to a server, right? But without leaving the React application, right? And then capturing the response and then updating the user interface accordingly. It's much like any modern web application is doing, right? If you go to Google Maps, right, and you start scrolling, right, obviously it doesn't load the entire world all at once, right? It'd be way too expensive. So instead, as you're scrolling and you're moving, the user interface is hitting the server, fetching more maps, right, to fill in the gaps of the empty spaces in the map, right? Or if you're scrolling through Facebook, right, or Instagram or Twitter or X or whatever, and as you're scrolling, that data, you don't have all that data all at once. So instead, as you scroll, you're telling the client, the browser or the application is going out to the server, fetching more data from the server, and then just filling in the empty spaces to, as you scroll up, right? So it's going out, fetching more data, and just filling it as it goes, right? Usually has like a fixed data structure with maybe 100 spots that loop, all the way through, and so you're always filling out the empty spaces, right, as you scroll up or down, right? So we want to learn how to do that. We want to learn how is it that we can send a request for data for the server, behind the scenes, capture it, and then update the user interface. How do we do that? So that what I just described is the Ajax or asynchronous JavaScript and XML library. Now, this technology was, became popular at the end of last century, beginning of this century, and it was for fetching data from a JavaScript application. Now, back then, the preferred data representation or data format was XML. So you had, so these programs, these JavaScript programs, applications, going to fetch data from a server, and it was encoded in XML, right? Now, the time has evolved, right? And the use cases now are mostly the data is formatted as JSON instead of XML, right? So a better name for this today would be asynchronous JavaScript and JSON. Okay. The other aspect of this name says that it's asynchronous, right? Meaning that the communication between the client and the server is going to be asynchronous, meaning that when the client makes a request to the server, it's going to be asynchronous, and that the client is not going to wait or block the JavaScript applications in a browser have a single thread, right? And so we jealously make sure that that thread is never blocked, right? Because it would freeze your JavaScript application on the browser. So what we do is that we rely on the browser. The browser can have many threads, right? It can run things in parallel. So JavaScript, what it does is that uses the browser and says, hey, here's a URL. I want you to go fetch some data for me. But I don't want to wait for it. You go do your thing, right? And the browser knows how to do that already, right? Browsers do that all the time. When you load any website, right? The browser opens up a whole bunch of threads simultaneously and start fetching stuff, right? Fetches images and CSS and JavaScript and content from a whole bunch of places, and then brings it together for rendering a screen. So JavaScript using Ajax, right, plugs into that technology and says, hey, here's a URL that has data, right? It has a whole bunch of tweets, it has a whole bunch of images from Instagram, it has whatever, right? It has a bunch of modules and courses, and so it goes and says, go fetch them for me. You know how to do that. Go fetch this for me. And I don't want to wait for it. Right? I'm going to go do something else. Right? And because I have to animate stuff, I have to stream movies, I have to cat videos or whatever, right? And so while the browser is talking to the server, fetching data, once the server responds and the browser has the data for you, the Ajax API allows you to establish a callback, right, or register a callback saying, hey, here's the data that you requested. Here it is, right? And so it interrupts whatever you were doing. The JavaScript thread is interrupted, and then we now continue execution at the callback and saying, here's the data from the response from the server. Do whatever you want with it, right? And then that's where we continue handling the request from the server, right? So that's Ajax, right? And the architecture, right? The explanation, the 25 words or less. Now there's a library that makes this very, very simple, right? Which is called Axios. Axios is the library that is going to allow us to use Ajax or implement Ajax applications within our React application. So I'm going to install that. So this is on the website of our application. I'm going to stop this and install Axios. Okay. So once that's installed, I'm going to restart. So what we're going to do is that instead of having hyperlinks to go and Redux. So it looks like I don't have that installed. Okay, npm install Redux. I don't have Redux? Really? Let me install that. What other complaint was there? And I guess I'm just missing React Redux toolkit. Let me install that. Let me start that again. Let me see. Okay. All right. So, so what we want to do is that instead of fetching the to-dos and leaving, we want to stay here, do the to-do, the fetch of the to-dos, but we want we want the user interface to update immediately here inside of the user interface. I don't want to have to go out to the server and display that raw data. That should happen all behind the scenes. I should not see that. Okay, so let's see how we would do that. Okay, so we install Axios, and so we want to basically do this. So we have the to-dos right here. See this URL? We want to do that, but without clicking the URL, right? We want to do that programmatically. So to do that, we import Axios like that. And we want to have a function that is going to call fetch, say, whatever you want to call it, fetch to-dos, right? That does the following, right? I want to call that URL programmatically without me having to click anything, right? On load, maybe I want to do this, right? So what we're going to do is that we're going to put this as a string, put it as a parameter to Axios, right, .get. Axios is going to get that, right? And so if I try it out, right, and here it is, and I inspect, you'll notice that if I refresh, are we in the right place? Where are we? Well, here's the function, but nobody invoked it. let's invoke it. Let's invoke it. So we'll say fetch like that. Okay, something went wrong, terribly wrong. Right? If you look at the error, it says that there is an access violation. Right? It says that you violated the course policy. Right? There's no access control allow origins header. Blah 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 blah. Right? So this is a so course, right, or it stands for cross-origin resource sharing, right? And it was expected, right? And we actually, make you confirm that you get the error, and it's because by default, JavaScript programs that are running inside a browser. Now, this is only JavaScript running inside of a browser have this flaw, this limitation. This is one of the limitations we were trying to fix, right? That JavaScript running on a browser is limited, that it cannot access the file system, can't connect to a database. It cannot willy-nilly make any network connection that it wants. And that's what we're trying to do here, right? Right here, we're trying to willy-nilly just programmatically go fetch something. Now, that's different than having a hyperlink that a user clicks, right? They are deliberately clicking on something, whereas this might be something malicious that a developer wrote, right, to spy on you or something, as opposed to a hyperlink that the user decides to click or not click, right? So this is some malicious developer might have like a little timer that is spying on you, and it's listening to your keystrokes, right, and it's sending this to some server or something, some malicious code, right? So this immediately is blocked, right? You cannot programmatically go out to any URL like that, right? And so this comes from a time where there was a lot of paranoia on JavaScript, somebody else's code running on your browser and taking over your screen or your computer, right? And so there was a lot of effort at limiting what browsers could do, right? Or the JavaScript running on a browser. So JavaScript are only allowed to go back to their parent server, right? So it is okay, right, if this would be 3,000. If this would be 3,000, then there would be no complaint. This would fail for some other reason, right? But not because of security, right? The browser would allow this to go through. It would fail because there is nobody listening at /5/to-dos. It doesn't match anything, right? But it would go through and it would be fine, right? Actually, I haven't tried it. Yeah, there's nobody listening. There's bad requests, right? Because there's nothing mapped to that. There's a 404, right? There's nothing there. Okay, so it fails for a different reason. 4,000 failed because it was violating a security policy. Okay, so how do we get around this? So the way to get around it is that understand what the browser is doing, right? So what the browser is doing is that it's checking with the target domain 4,000. It's checking to see, hey, this 3,000. It's this script is running on this domain, different domain 3,000, and it is. I think it could be malicious that it wants to talk to a different domain. That is fishy, right? Are you okay with it? It asks the server. It asks the server, and maybe we could see it here in the network. Okay, so in this network, preview response. No, yeah, no, you see it. You see it just here. Course violation in red. Yeah, course error. Okay. And so it goes out to the server. The server responds saying, okay, yeah, I don't know them. I don't know them. Okay, so I'm going to reject that, right? I'm not going to allow it to go through. And then the browser stops the communication and says, nope, the server that you were trying to communicate doesn't know you, right? So you're not allowed to talk to it, right? So, but we own the server. It is our server, right? So we can actually change the behavior of our server, right? And the way to change this is by using a library called course, right? So let's install the library course so that we can configure the course policy. So we can tell it, stop whining, right? Let it go through, right? I know I'm the author of this other program, right? This other React.js application. I want these two to trust each other, right? I trust both, right? That they talk to one another. So we're going to install. So I'm going to do npm install course. And this is going to allow us to configure how it should handle the course policy, right? So we're going to do import course from course, right? And at first, what we're going to do is that we're going to just say, trust anything from anybody, right? Later, we'll see how we can narrow it down, right? But for now, we're just going to open up ourselves to anybody, right? So we're going to say, the way we do that is to say that app.use course, right? So we've been using app.get, right? So that means that those app.gets are only handling HTTP GET requests, whereas app.use is handling any request. So any request that comes in, configure the course policy. And this course policy, you can configure it by providing here an object that configures a whole bunch of properties, right? Like for instance, you could say, well, I only accept requests from localhost 3000, which is what we're doing, right? But here we're going to, if we don't provide any option like that, we're just saying that we accept requests from anyone, right? From anyone, right? So let's leave it like that for now. Later on, we're going to revisit and narrow it down a little bit. Okay. So let's restart this. Node mon. Now, if we try this again, so this time around, it did not complain, right? It didn't complain, and we can see in the network that it went to the to-dos, right? And notice that the response is the data. So this data now is in the client, but we haven't been able to grab it yet, right? We haven't been able to grab it. It came back as a response. There's our header, went out to localhost,
4,000 blah, blah, blah to-dos, and the response came back as what we want. We need to grab it somehow, right? In the UI, we need to grab it somehow, and then somehow make it available in some variable so that we can iterate over the array, you know? Okay, so how do we do that? Well, what we can do is assign the response from this GET request into a local response object like that, right? And then we can print it out. Let's see what this response is. Let's see what's in there, right? And if we look at the console, it's not the arrays. It's some weird promise, right? What the heck is that? So unfortunately, yeah, the response doesn't necessarily actually contain any of that data, right? So let's talk about what that response, what do we mean by that promise? Right? So okay, so we fixed course, right? So we went over, we overcame that challenge, right, of the security. Now we have to overcome the fact that the communication between the client, right, our React application, and the communication with the server, that communication is asynchronous. Okay, and what we mean by asynchronous is that, right, it doesn't execute, you know, from top to bottom and from left to right the way we normally think of programming, right? Things execute in a particular order, right? Next, and one of the more common features is that, right, if you call a function, like here, we're calling this function, your expectation is that the current thread would block, right, would wait until that function is complete. And when it completes, right, it comes back with the result of that computation from that function, which is whatever, and then we assign it to some variable, which is the result of the computation. In our case, our expectation was that this would be the response from the server, right, and that we can then look at what the server sent back, right, which is the array. Unfortunately, this is not executing sequence. It's not synchronous, meaning the thread that is running through this sends the request. Yes, the request goes out, but it doesn't stop to wait for the response. It doesn't wait, right? Because again, there is a high risk, right, that this request will fail, right? Because you know, the server might be down, right, or it might be taking too long. There might be some network issues, right? So if I have a thread block waiting for this response to come back, right, it could happen that you know, my application blocks, right? That I'm clicking, I'm dragging, and nothing is working. You know, why is this not doing anything? Oh, because the thread that would otherwise be handling your clicks and your drags, right? It's busy, it's blocked, waiting for the server to respond, but the server's taking too long, right? So, the way that this is handled is that we don't block, right? We send the request, right? And then at some point in the future, we would like to be notified when the request was fulfilled, right? So how do we do that? Well, because this is not the response, we get a promise. We get a promise, and the promises are objects that are used for synchronizing things that are asynchronous, right? And we do that all the time, right? Like for instance, when you, for instance, the difference between two communications, for instance, a phone, when you're talking to somebody on the phone, that's a synchronous way of communication. I say something and then I wait for you to respond, right? And then you say something, and then you respond, and then I say something, and so we're waiting on each other, right? And it's sequential, right? An asynchronous version of that is text, right? Meaning, you know, I send you a text, but I don't wait for your response immediately. I put down my phone, I go do something else, and then I hear, bling, bling, that a response came back. So I then come back and I see your response, right? So the synchronization mechanism here is the notification, right? I notify you that, hey, here's the response. So same thing here. We want to have a mechanism where I send out a message, but I don't wait. I leave something for you to notify me when it's done, right? So that you can call me back and I can hear the bling bling, right? The response came back. So I can go back and read it, right? So that's what promises allows you to do. Promises allow you to leave a callback, right? So that you can be notified when the response is done, okay? So how do we do that? So the way it works is that the promise provides a function called then, where you can leave a callback function, right? That will be invoked sometime in the future when the response is actually available, right? So that you register the response, and then the script, the thread goes and does something else. When the response comes back, it will call that function, right? And it will pass you the actual response. Right, we'll pass you the actual response that comes from the server, and then we can print it out. We can do console response. Now we can see what's inside of the response. All right, let's take a look. So there's the response. Here's what comes back from the server. The server comes back with a whole bunch of meta information saying that the request was good, right? The status was okay, right? The headers, blah, 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 and the data. Look at that. That's the data. That data is what now we have a hold on that data. I can actually just print the data, say response.data. There it is. See that? There's the array for the data. And now I can use that data to do something in the user interface. Perhaps what I could do is create here a state variable that contains the to-dos. Right? That at first it's an empty string, an empty array. And so, but now I can populate it. I can say set to-dos. I can populate that state variable with the to-dos, right? And I get into an infinite loop, right? And so I'm going to stop that. And the reason it gets into an infinite loop is that this function, when it sets the state causes this to re-render. And the re-rendering causes the function to be called. And the call sets the state, and the state makes this to re-render. And the re-rendering calls the function again. So somehow what we want to do is that this function, we want to guarantee that this function only is called once. And right now, the way it's implemented, it's causing it to be called infinite, right? So the way to fix the infinite loop is to use something like a constructor. If this had a constructor, right, where it's constructed only once, right, then in the constructor would be a good place to call that fetch to-dos, right? But we don't have a constructor because we're inside of a function. Functions don't have constructors. So the next best thing is a use effect hook. So the use effect hook allows you to declare things that should only happen once, right? Or should happen, you can control when things happen, right? By default, things only happen once when the component first loads, right? So this use fetch to do is we want to configure this to happen only once when it loads the first time around, right? So what we do is as follows. We say use effect, okay? And then we wrap our fetch to-dos inside of the use effects, right? And then we make the call. Everybody good? So now we can go to localhost 3000 labs A5, and this should no longer be an infinite loop. Okay, so no infinite loop. No infinite loop. But guess what? Now we have the to-dos in our array. So we should be able to, right? Working with arrays, we should be able to render to-dos from server. So to-dos from server, we should be able to just iterate. List group. Iterate over the to-dos, display the line items, the title, and the UL. And there they are. Why there is an empty array? Oh, yes. Yeah, let me talk about that. Okay, so this empty array is saying, right, that I only want this to happen once, right? Only when this first loads, and then never again, okay? What this array allows you to do is declare dependencies. Declare and say that, hey, actually, I don't want this to happen just once. I want it to happen every time that something changes. If this variable, this would be a variable, right? If that variable changes, then I want this to execute again, right? And this could be perhaps a parameter, maybe something in the use params, right? Maybe the ID of a course, the course ID. And so if the course ID changes, then I would want to go back to the server and fetch information about that course, right? But right now we don't have anything like that, right? We just have nothing is changing over time, right? But if I had a parameter out here, right, that I want to parse, and that if you type something else, I want to update the component, then I could, make a dependency so that whenever that changes, I could list it here as a dependency, and then it would cause the fetch to happen again, right? But because it's empty, we're saying there's nothing that would cause this to ever happen again. Okay? So it's the equivalent of just like a constructor, only happens once. Make sense? All right. Yeah, so we have that. Now this syntax here of the promise and the .then and then the embedded URL function here, that's a really tough syntax to understand, right? I mean, you're gonna scratch your head on that. It says, wow, promise .then, a nested callback function, and oh, that looks horrible. Okay, so this is a syntax that is falling out of favor, right? It's an older syntax that is still widely used, and you'll find it a lot in documentation about working with APIs, right? So that's why I'm covering it. But I'm going to abandon it, right? Now that you've seen it, I'm never going to use it again, right? Well, actually, I think the assignment, gives you examples of both, using the new syntax and using the old syntax. Feel free to use whatever you want. I would suggest using the newer syntax, and let me explain the new syntax, and you'll be happy. You'll be happier with the new syntax, I think. So this fetch to do. So I'm going to leave this alone, right? I'm going to leave it. I'll call it I'll call it the fetch to dos, and I'll call it promise, right? The promise version. The promise version. Okay, and I'm not going to use it. I'm gonna comment it out. I'm not going to use it, so it's not fetching anything, right? No, it's not fetching anything. So let me re-implement this using a different version. Okay. Yes, fetch to do is async. My AI is already knows what I'm doing. So in this new version, it's gonna. So let me do it this way first. What we would want to happen is we would love for this to read as follows, right? We would love to say, const response equal Axios, like that, right? And then we would want to do, set to dos response.data. This is what we would want this to be written. That's far more easier to read than this. Would you agree? Okay. The problem is, of course, that this is a promise. It is not the response, right? So to be able to write it like this, right, we can use a new syntax, right? That what it does behind the scenes, right? If you write it the way I'm going to write it now, in the behind the scenes, it writes this, right? It compiles down to that, you know. So let me show you. Just by saying that this function is async, like that, and that this function is await, boom, you're done, right? This behaves the way you would expect, right? I'm waiting for this as if I would be blocking, right? And waiting for something, and then the response gets unwrapped from the promise. Now I have the response, and I can use it as if this were sequential. What's really happening behind the scenes is that the compiler is converting this into that, right? But the compiler does it, not me, right? And so now I can use my fetch to-dos. And this works now the way it worked earlier. Yes, right? So, you know, I would encourage you maybe try these older syntax a little bit, since it's really, really what's happening behind the scenes. That's what's happening really behind the scenes, okay? But this newer syntax is just as good, right? And it's easy to read. Okay. All right. Yeah. So let's do the create. We had a link here for create, I believe, right? Fetch to dos. Didn't we have to create? No. All right, let's do it. Right. So we have an API here for creating, and it was really this one, right? So let's do that, and it returns all the to dos. Right. So let's implement that. Right. So we'll have a const create to do, and we want to invoke this right here, right? So we want to, I'm going to copy this. I'm going to say, I'm going to use the new syntax, async, right? And this is going to do const response. It is a get to-dos, and this is a create, right? Like that. And response to-dos like that. Okay, so this is a create to-do. It goes out and does this, right? It does this right here, right? And it creates a new to-do. You know, it's as if we do this, right? If we go here and we fetch the to-dos and we do a create like that. It says /create, it creates a new one, right? So we are going to do this. We're going to do it from our user interface. There it is. /to-dos create. Okay. And when are we going to call this? We're going to call this when we have a button here that says, when we click it, create to do, it's going to invoke, go back. Notice when we create the to do, notice that it creates these new to dos there. See that? Every new to do. Everybody good? And when it comes back, is it's all the to dos are in the promise, and we are sending it and updating the local set to dos array. Right? How about delete? So delete worked as right here, right? This is the URL. So let's do that. Let's implement that. So we would implement here a. Now I'm using this this string all over the place. So a good practice is to declare a constant to do's URL or API to do's. And then instead of just repeating this all over, right, we can just say to-dos API, right? And so if we create this delete, const delete or remove to-do, I'm going to pass the ID of the to-do that I want to work with, right? So I'm going to do a get. So this would be the to-do API slash, we need the ID, right? And then delete like that, right? So that's the URL. Then I'm going to, the response is going to contain the surviving to-dos, and I'm going to call it from a button, a new button that we can add here. It is a button class, maybe button danger. When I click it, I'm going to call remove to do. I'm going to pass the to do ID, and this is going to say delete. Okay. The question on chat: are we using a get request to create here because we are expecting the API to return all the to dos? So we are misusing get. Now, normally we would not be using get, right? We would be using post, delete, and we're going to do that in a second, right? I'm using a get because it's the easiest to understand the interaction with the server. But yes, you're pointing out something interesting, right? That get, right, like the name suggests, is for getting data, right? Retrieving data, not for creating, removing, updating data. Although we are using it for that as well. Right, and so in a second, we're going to transition and introduce the other HTTP methods, post, delete, put, but also you're pointing out another good important aspect is that in all our requests, we are always returning all the to-dos, right? And I will talk about that in a minute, right? So let me also float this at the end. So now we have these deletes, right? And so I can click on these deletes, and they're removed, right, from the server, and I get back the list of all the to-dos, and I display the surviving to-dos. So I can create new to-dos, and I can delete the to-dos, and I can refresh, and my changes are permanent, right? As long as the server keeps running, right, it remembers what's in the array and what's not in the array, right? And then finally, I could update a to-do. So I can maintain here maybe a to-do variable that at least has the title, right? Right, that maybe I can edit, right? I can maybe, well, I guess this can be empty. And that if I click on that, and I can say I can render maybe an input field here. I can render an input field, say input class form, the title. Did it implement the whole thing for me? Title, blah blah blah. Set title. Do I have title? No, I don't. Do I? No. Oh, I do have title. I do have a title. Wait, did I implement that already? Oh, I do have a title. I do have a title. All right, so I guess I could use that. I can just reuse that, right? There it is. Here's the title. I can edit that, and then I can update the title, right? I can say, again, the const update title, right, is what? Is the URL is this right here. A to-dos title, blah, 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 right? So that's const response. So ID, right, the ID title, and then the new title. That's right, right? And then I'm going to set the to-dos, and that gets changed. All right, let's try it out. So if you go here and then I need to, how do I select which I'm editing? How do I select the one I'm editing? How do I select the one I'm editing? I guess I had an ID here somewhere, don't I? I have one, right? So that if I click on the update to do, create a button here, that calls the update title, right? And here's one, and I'm updating this one. If I update, it didn't work. Is the ID? Well, why did it fail? Let me see. Here's the ID. I update. What is the request? Oh, look at that. Slash to-do's title is as an object. So the ID is not being, and then let's look at the request, the whole request network. We can see that this is what went out. Okay, we can see localhost, blah, 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 slave file. So this was supposed to be an ID, right? The title, and then the undefined. So that didn't work, right? So let's see where our URL broke, right? So this ID, where is that coming from? Is that ID, and what am I passing? I'm passing, oh, okay, there it is, the error, right? I need to pass in the, it's expecting what? It's expecting the ID and the title. Okay, I see. Expecting the ID, which is, do I have a field for ID? Yes, I do, there it is. And I'm gonna pass in the title as I type it. And then here I'm using for rendering. Okay, so let's try it out again. Let's clear this out. Let's try this out. One, changes to go to work. I'm gonna update. Let's see. Looks as the go to work works, right? So A5 to do's one, title, and go to work. Why is that not to do's one? Are the IDs wrong? Maybe the IDs are wrong, and I don't know what the IDs are. Oh, 3. It was ID 3. So we need to know what the IDs are. So I don't know the IDs, right? So a good thing that we could do is that we can display next to the title, we can also display the ID, right? So let's display also the ID here. So if we go back here, now we see the IDs, right? So we want to change 3. I can change it here to 3, right? And I want to change it to go to work. So I update, there it is, see, it changed. If I want to change this one, right? I can set the ID, right? And then I can update the to-do title to be, go to sleep. And then update, and it changes like that. See that, right? Okay. So this is a very rudimentary way of doing it, right? A much better way is to instead not use get, right? And that's where the next topic comes in, right? So we've implemented this fetching arrays, blah, blah, updating arrays, deleting arrays, right? Now, the proper way of doing this is to instead, right, use the correct methods for the correct things. Right? So get is fine. Get is for retrieving, right? But if you're going to create something new, right? If you're going to create something new like we're doing here, where we have this create, right? It is a bad practice, right, to use anything other than nouns, right, in the URLs. Here we're using a verb, create, right? So the convention is that only nouns and primary keys should go on the URL, right? No verbs or adjectives or anything like that. Only nouns, plural nouns, right? And IDs. And instead, the verb should move to the method. The method which is also called an HTTP verb or an HTTP method, can be any of several, right? In particular, the ones that we're going to be considering are these four, right? Or five. Get is for retrieving data. A post is for creating data. Put is for modifying data that already exists. And delete is for removing data that already exists. Right? And options is, we'll see that in a minute. So we've been using get for everything, for creating, for updating, for deleting, right? But the convention is that for creating, we don't use a verb in the URL. Instead, we use the verb post, right? So let's do that. So here what we're going to do is that we're going to re-implement this. So just copy this. All right, so it's going to do exactly the same thing, but now it's going to use the correct convention. Okay, and so the convention is that we don't use the verb in the URL. Instead, we use HTTP post. See that, right? Also, the convention is that the data, whatever data you need, right? Well, not all of it, but some of it will come from the client, right? And it will be passed to you in the body, right? But before we do that, let's see if it works. Let's do the post. Let's see the post example. So we can come here, right? And let's create instead of a create to do, I'm going to call it a post to do. I'm going to post a to do. Post. And this is going to be a post here, and it's not going to be a create right there. So I'm going to be hitting that URL, right? And here, the button, right, where we do the create to do, I'm going to add another one and call it post to do. So post to do, and it's going to call post to do, like that, right? So if we go back to our URL, there's our posts. And if I click on it, notice that it works just the same way, right? I'm adding several. Let me remove a few here, right? And if I could just keep hitting it, so it's doing exactly the same thing, right? And you'll see that these requests are being sent to the browser, to the server as posts. See that? Right? Not as gets. So this is the proper way of implementing things. Right? The other thing is that, for instance, we could use this input field to send the default title of these to-dos, right? So that they're not always the same new to-do or whatever. So for instance, what we'd like to be able to do is to pass along, we can pass along data to the server, right? For instance, we could pass in an object that has an initial title, right? And the title could be something that we type at the command line, at the URL, at the input field, right? And so that object would then be available, passed over to the server in the body, in the HTTP body, right, as an attachment, okay, which would then be parsed on the server side. So the way we get it on the server is that in the request, the object is in there in the request, right? So we could, remove these and then spread the body, right? The JSON object that is sent over to the server, right? In the body, we can extract the body, and presumably it will have the object that you sent me, which right now, the object that you're sending me just contains a title. That's all it contains, right? So the title should be in here. Let's try it out. Right. So here, so if I post, right, notice that the title is not working. Okay, let's remove these. I'm posting, but the title is not there, right? If we look at what I'm sending, if I look what I'm sending, the payload, I am sending the correct title. I am sending the correct title in here. But the response that's coming back is that the title is not being copied into those objects, only the ID, which is being created on the server. Now, why is that? Well, it's because the body can contain any number of embedded or attachments, right? It could be an image, it could be a movie, it could be a song, right? It could be anything, right? It could be text, it could be an XML document. So the server doesn't really know how to handle, just arbitrary attachments, right? Arbitrary data, right? We are sending on the payload this JSON string, right? It's just a string. So it doesn't know how to handle this particular data type, right? So you have to configure it on the server. So let's go on to the server. Now on the server, we can turn on JSON parsing, right? Using this configuration. We can say app.use express.json. There it is. So Express already has a parser, a JSON parser, which we can turn on by creating an instance of it and passing it to .use. So .use is, for every request, that comes in, do this. And what we're doing is that we're parsing to see if the body contains anything. Try to see if you can parse it into a JSON object. And now this will contain the actual data, right? So let's try it out. So now let's delete all these. Oops. 7.5. Okay. So now if I make it a little smaller. So now if I say posts, notice that it has to go to work. See that? Feed the kids. Post it to do, and then so now the data is going out, and we see that the data is going out, and the response does contain the title that I sent over in the body, right? One other thing here, notice that there are kind of like the two to-dos. So this one, if you look at the heading, right, notice that this is my post. See that? That's my post right there. But the other one is like another one that says options. I didn't send that. What's that? What's that all about? So that's part of the course policy. The course policy works by the browser first going out to the server and asking for permission and saying, hey, is it okay for this script that lives in some other domain wants to talk to you? Is it okay? And so it makes the post, right? And then and it requests options. So it's not a post, it's not a put, it's not a delete, it's a options. And then the server responds with what is allowed. What is it allowing the request? And it responds that it is okay for the browser to do a get, a post, a delete, a put, basically anything, right? And then so based on this list, it checks to see your next request. So if your request is included in the options, then the browser lets it go through, right? If it's not, it's going to block it, and it's going to give you a course, access, blah, 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 whatever, right? And stops the request, okay? All right. All right, so we did the post, right? We fixed the post, right? What about these other ones, right? The this delete, right? Where we're doing the delete. Where's the delete? Here's delete. Again, the correct implementation is that. So let's copy this. Correct implementation is that we don't use the verb, right, in the URL. Instead, right, we use the delete verb, right, in the type of request, the HTTP method, right? And it works identical, right? So we can go back to the client, right, and re-implement it. So in our delete, in our remove, let's implement another one. We'll call it delete to do. So delete to do. It's going to use a delete here, and don't use a delete. So that's what goes out to so this is the browser sending the delete request, right? So these delete buttons, instead of calling remove to do, I'm going to call delete to do, which uses a delete method. Okay. So let's try it out. This should work identical, right? So this still should be able to delete the same way, right? So we did delete, right? We retrieve, right? We're able to create, okay? And yeah, so those are the various CRUD operations, okay? So yeah, so next week we're going to be taking a look at using these techniques, right, to implement Canvas. Right, so we're going to move all the data that we had initially in the browser, right? We had a database, right, in the browser that contained all sorts of arrays for assignments and courses and modules, right? All that, we're going to move it over to the server, and we're going to create APIs like this, right? So that we can manipulate them, right? We can read and retrieve them from the browser, right? And we can then also create new modules, delete courses, update assignments, right? Using these APIs. All right. Anyway, that's all I had for you today. Any questions? Oh, okay. All right, Wembo, let me take a look at it.
Hey, Professor.
Yes.
Yeah, can I ask you a question about the assignment afterwards? After
Sure, go ahead.
related to the lecture. I mean, if anyone has any questions about the lecture, they can go first.
Any questions in the lecture? Yes, Chia. Can we use a string? Yes, you can use a string as an ID in the database, correct. Yes, I will be uploading it tonight. Whenever Canvas makes it available. Sometimes it takes a little bit of processing before it's available for download. Matt, do you have the question?
Yeah, so I gotta share my screen, so
Yeah,
it'd be great if
I need to stop sharing.
oh, do you want me to share
Go ahead.
in this room? Okay.
Yeah, it's fine.
Can you see it right now?
Yes.
Can you see my ID?
Yes, I can.
Yeah, so I'm working on the extra credit, and I have like wrong behavior for deleting and adding the assignment. So when I click the assignment and trying to add something new,
Yep.
it doesn't add anything. But when I click some assignment that already exists, go back, then try to edit, it adds. And also when I delete it, it doesn't delete the assignment item that I'm trying to delete, it deletes from the bottom. So if I delete this one, it deletes the last item. So I've been trying to fix this issue with two different TAs, but they couldn't really resolve the issue. So I was wondering.
All right,
if you can
so
help me with that.
all right, can I see when you add the what do you do when you click on the assignment? You just navigate, or
You mean when I click the assignment item here?
no? When you click on the plus assignment to add assignment, what do you do?
When I click that one, I go to.
Do you just navigate?
I use link. So yeah, navigate. Yeah.
Okay, so you're not actually creating anything yet. When do you actually create it? When you click on save in the editor?
Yeah, so inside of the assignment editor,
you click on save, right?
Yeah, when it's assignment editor based on the URL. If it's assignment editor, it means we're trying to add new assignment. So if it's assignment editor, I'm adding new assignment using add assignment.
Okay, and so you're saying add assignment, and and so assignment is a use selector. Okay, so it's the one you're editing, and it's in the. Okay, I see. Why are you putting it in the curly bracket ... assignment? Why not just assignment?
Yeah, I was referring the module list, so maybe that was the issue.
Yeah, no curly brackets at all. No, go back.
Here?
Yeah, why curly brackets at all? Yeah, remove that curly bracket.
I'm not sure. Yeah.
Okay, so go. Let me see your implementation of add assignment.
Add assignment is here.
So add assignment. What are you doing here? You're doing action payload, and you are you're copying that. Perfect. And then you're adding an ID, the string, and then you're appending all the assignments. That looks right. Yep. And then wait a minute. State.assignments equal. I think that's right. Okay. All right. Try it. Let me see. Refresh. You say add. Okay, and type something, whatever, A4. Then save. It doesn't add it here. Okay, can I take control?
Sure.
Let me see. Okay. Can you go back to your browser? Let's see. So this is the assignment editor. So it's the assignment, right? Okay, and where is this here? Canvas, course, assignment.
Assignment, yes.
This
assignment
one?
Editor.
That one?
No, the assignment editor. Click the assignment editor folder.
Oh.
Yeah.
Oh, okay.
The index.js.
Okay, and where's the reducer?
Reducer is right there. Assignment reducer. Go up a little bit.
Oh, this one.
Yep.
And this is the add assignment. So when you, oh, interesting. Did you just type this?
Yes.
Wait a minute. No, I want to start from scratch. So, like, huh? Why is this like that? Did you type this?
Yeah, that's the no. So I typed the. So I was trying to make a new
Okay, let's see.
assignment.
Okay, here we go.
Then
So
Mhm.
here's the payload. That's what I just typed now.
yes.
I just typed that, and then save this. And okay, so how are you retrieving this? Can I see that? Where is that in the assignment? Is that here? Assignments. Where is that? Is this assignments?
You mean the assignment status?
Yeah, this.
Oh, here.
Is it this one here? Is it this?
Yes. In line 48, it is iterating the assignment.
Yeah, but how are you retrieving it? So here are the assignments. Assignments. Is this what you're iterating over?
Yep.
Actually, no. Oh, you're filtering.
In the line 16, I get all the.
So wait, what is this assignment then? How is this different than this? Oh, you're filtering. Okay, I see. You selector, blah blah blah, course, assignments, filter, yada yada yada, assignment, course ID. Okay, so let me put a breakpoint here. Let's try that again. Okay, we're gonna continue. Okay, what do we get here? Assignments. Oh, so there they are, right? So they're being added. So my guess is that they don't know that you are part of the course ID, right? So when you're adding, go back to the code. So when you add, right, this is the add assignments, right? Oh, maybe that's what you meant to do. So you have the course ID here, right? Probably what you tried to do was to append course ID, right? So that you know you're part of that course, right? So go back to your browser. So let's refresh. So we clear out and let's empty that. Go back. Okay. So we add an assignment. There it is. See that?
Oh.
Yeah, I just didn't know that in your filter, right, that you were part of that course, right?
Oh, then when I delete it, yeah. Another problem is that.
So how are you deleting though?
Let me go back to the code. So this is my delete assignment.
And so you're passing, what is that? So I'm guessing you're passing an ID. So also you have to be careful, right, that these are the correct data types. When you create this, okay, it's a string. And is the database all strings? Oops.
Yes.
So the courses.
I think so.
Okay, they're all strings. Okay, good. Okay, so that's correct. So again, I would step through this and check to see if this payload is correct. So, but let me see. Where do you send where you do the deletion? Where's the delete?
Yeah, there.
Button?
So here, I created what is it? The delete model, and inside of this delete model, I called delete assignment.
What do you mean? Oh, delete model. Okay.
Yeah.
Okay, and then you pass. Okay, so where are you getting this ID? Are you passing along here?
Yeah. I was trying the assignment ID. I was trying to take the assignment ID as a parameter. So here, I'm taking the assignment ID from this assignment when it is iterating?
Okay, maybe that should work. That sounds right. Assignment ID equal assignment ID. That looks right. But anyway, we would need to do a breakpoint on the delete model, make sure the ID is correct. Now, when you click on it, you are getting the correct ID. My guess is you're not, because this is not a what is a closure, and my guess is that it's the last ID. It's the last ID of the last assignment. Maybe that's why it's always removing that one.
Yeah, then where should I start to fix that one?
I would handle this here, right? You have the click here, right? Delete model, but the event handler is here, right? Where you have the you pass the object assignment, right? And then when the on click, it would you would pass the on click here, right, as an attribute that you can then call, which would invoke your dispatcher here. Actually, you could do the dispatcher on here too. You could move all that dispatch stuff in here instead of the delete model and call it from there. Right. So I mean, different ways. I would go with a like you did here on unclose. You can pass you can pass a function that when you click on that function, it calls you back. That allows you to then dispatch the delete. So try that.
I'm a bit lost. Could you repeat that one more time?
So you have here a cons delete callback, right? And this is so you would invoke here, alert delete, right? And then you would pass in here delete modal delete callback. You pass in as argument the delete callback, right? Then in the delete model, so this button, or right here, you're calling this here, right? You can invoke the delete callback here. So you can invoke here delete callback, right? So that can you go to the browser? And so when you click on this and delete, does the alert? See this alert? So it's calling back. And now go back. Can you go back to the code? Go back to. Can you go back up to the parent? The assignments. Okay. So this delete, and you can now do. Now this is a closure, and in the closure you can say, dispatch. What is it? Dispatch. Delete. What was it? Delete assignment.
Model. Yeah.
Right, and you call assignment dot underscore ID.
Oh.
Wait, do I have an extra parentheses? Okay. Right, and dispatch blah 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 blah. And so here now you console dispatch on close delete, right? And so now go back to the browser. So now let's delete this one. No, that didn't work. Propulsion? No. Interesting. Wait, is it calling that one? Where's your assignments?
Assignment.
Is this it? Okay. Oh,
Yes.
can you go back to the code? Yeah, here. Can you go back to the wait. Can you go back to the browser?
Sure.
That's not the one, right? That's
Yeah,
wrong.
it has to be 1-1.
Yeah. Modal. Yeah, they're all being created with the last one. They're all being created with the last one. Interesting. Interesting. Wait, go back to the code. Go back to the modal. So you're passing presumably the assignment ID right here, right?
Mhm.
And are you sure you want to assignment and then assignment ID? Go back to the code. I mean to the browser. Yeah, it's wrong. See that? They're always the last one. Always the last one. So yeah, it's being passed by reference
Yes.
and it's not by object. Go back. Go back. Modal. ID. Also, ID. Wait, where's your? Wait, is this course map? Use assignment. Assignments. That's the whole assignment. Yeah, the assignment. Go back to the browser. Wow. Go back to the code. Wait, did we refresh? Yeah. Wow. Go back to the code. What is going on? Wait, this is not being displayed. It is not being rendered. So how are you displaying it? What is this done? What is this on close? It is because it's not being rendered. How is it not rendered? How is it that you pop up? Can I see the assignment? Okay. So here it is, right?
Yeah.
Where is it that, why is it not displayed? On close pop-up. Okay, so is this a component that you wrote?
Yes. But what do you mean by not displayed? Because the pop-up model is displayed right now.
What do you mean pop-up model is displayed right now?
So like,
It's open. It's open.
Yeah.
No, because so I think this is the problem, right? Because it's not open. This is not rendered, so it doesn't actually see any of this. So let me. It's open. Let me remove that and let's render it, right? So now they should all render, right? Go back to the browser. So let's refresh. Okay, so there should be 3 of these, right? So where are they? Pop up.
Isn't this pop up itself? I'm actually not sure. I'm so confused right now.
No, I mean, you implemented this, right? I mean, there should be 3 of these, right? One per assignment. There should be 3 of these rendered. No?
Why does it have to be?
In your code.
Because
go back to your code. Go back to your code.
Because Go
back to the assignments. Right, you're iterating here, right? You're iterating.
Mm-hmm.
You have this auto, and so this is being rendered 3 times. 1 per assignment.
Or maybe they're overlapped since they're displaying on the same position.
Yes, actually, all 3, one on top of the other, and the last one is the one always on top. So maybe that's what's happening. Is that they're all right on top of each other, and the last one always renders last, and you don't see all the ones behind it. That's what I'm trying to see. That is open. What is this? Is open pop up? What is that? Okay, so is this a okay? So you have one state variable controlling all 3.
Mm-hmm.
Yeah, you need a state variable inside. So you need this inside of your delete model, and then each delete model knows whether they're open or not.
Okay. Got it. Oh my God. Thanks so much.
All right. Okay.
Thank you.
Good luck. Good night.
Good night.
Hey, Professor, can I go?
What's up?
I actually have a very similar issue. Can I share my screen?
Go ahead.
I don't think I have the option to do that.
Yeah, no, everybody can share.
Really?
Yeah.
Oh yeah, now I see it. Yeah. Yeah, do you see my screen?
Yep.
Yeah, I'm facing a similar problem, but I think mine's a little worse.